There's no oh, here. This means the camera is on.
It means you already recorded.
Then is the camera on?
The camera is turned into blue. Yes.
Huh?
And
Is this the camera on? Where do I know whether the camera is on or not?
wait.
Here? I don't, 看不到。
这个音
我们都是用这个。We always use this one.
Okay.
This means that, you can show it here and also show what I have it here.
Oh, it's like a share screen.
Yeah. This is desk. So this one and this is camera. And they will do that. Both this one. Is it on? Okay. Make sure. Okay. Right. Okay. Okay, I'm going to talk about chapter 6. And some part of chapter 6 is a little bit complicated. Okay, you know that we're not getting all these chapters simpler and simpler. It's always more complicated and more complicated, right? Okay, this is the fact. On camera, on. Okay, and I wanted using the examples, continue my examples last week. Okay, and this example is, again, it's very familiar. You are very familiar with it. Okay, it's the Woody 3. It's about the restaurant, and you understand that the Y variables is the number of customer bills, and we have 3 independent variables, which is N, P, and I. N is the competitors. Okay, the P is the population in the area, and I is the median income. Okay, and we know that N with Y has negative relationship, and P and I with Y has positive relationship so far. Okay, and the reason we choose NPI is because of the literature review. Okay, we know that there's 3 variables, competitors, the people, and also the income is 3 important factors to affect the customer bills. Okay, so if after we doing this literature review, of course we will choose these 3 important variables included in the model. And I'm going to say is sometimes we made mistakes. If I know that I will have 3 variables, N and P and I would not make any mistakes about it. But sometimes we do know that although I have N, P, I, 3 variables, maybe I would not able to obtain one of the factor. Or I really just don't know that I have 3 variables, I just included 2 variables only. Okay, in other words, I will omit 1 variable. Okay, and today I'm going to say is that if you omitted 1 important variables, what is the consequences about it? So you see what I'm saying here? So this is the first section in chapter 6. We like to talk about is let me see. it's about omitted variable, okay? And all the expressions from the textbook is pretty, just very theoretic view of it, okay? I like using the real examples to show all these numbers, okay? So the first one is the correct model. Okay, I like to show this one here. I put this one here. Oh, I'm sorry. Okay, I put this one here. Okay, look at this one. It's the one with y and 3 x variables. Okay, and the first one I'm going to show is that if I neglect one of the variable, which is p, so I just have n and I. Okay, and from the first one, n, p, and I, is p is a very important variable. The first one. Is it p important? Yes. Why? Where did you see? No. Just looking at this one. Okay, you don't have this one anymore. Okay, just look at this one. How do you know that p is an important variable? Where did you see? What's the information provided from the output, and you know that p is an important variable? I mean the probability of the p, right? Which tells the beta, this beta 2, okay, according to the order. Okay, the beta 2, doing the hypothesis testing, beta 2, p and y should be positive, right? So after doing the hypothesis testing, we know that if we reject the null hypothesis, means that the beta 2 has positive relationship with y, right? Because of the probability. This is what we call p-value approach. Okay, so p is an important variable. However, maybe I'm in somehow, some way, I made mistakes. Okay, I just have n and I included in the model. So I'm telling you that in the future, if you're working with your thesis, suppose this is the correct model, but somehow, some way, you estimate the regression model is like this. Therefore, in this case, you omitted one important variable. Okay? You may not know. Okay, here, just for teaching purpose, I tell you this is a correct model, but this is your estimating model. Okay, then what happened? You just have this result because you don't know that p is an important variable. So now we get to the place that you are doing your presentation to your advisor, or maybe you're just working on the defense. Then one of the professors tell you that, oh, just wait a minute. You may bump into the omitted variable problems because, there's another variable called p. Then what would you do? This is the purpose for this section, these chapters. Okay, from my teaching point of view, I need to ask you that why do we learn this topic? And why it is so important that you have to know the consequences of omitted important variables. Okay, so in this case, you can see that this is the correct one, and this is the you run the model. Okay, what's the difference between these two in terms of the coefficient? You know, the correct one is negative 9074 something, but the one you run is only negative 87. And also for I, the correct one is 1.28 something, and the one you run it is 2.32. Okay, so in other words, from the correct one and the one you estimate, in terms of the coefficient of I, the one you run it is upward bias. When I mean upward bias means the number is more than the correct one. Okay, then how about N? N is negative 9074, and the one you just run it is negative 1487. So again, this is upward bias, right? Okay, so in this case, you know that the model you run, which we wanted to know the coefficient of the model and also the significance of the variables. Okay, and although the significance here doesn't affect the result, because this N and I here is also important, and the N and I here is also important, but the coefficient is upward bias. Okay, so now we add it to the problem is that how do you know the model you run it is upward bias or downward bias? You know, sometimes it's downward bias. This is upward bias, right? In other way, if you omitted the important variables, which like this example P, then the consequences will be the estimation of the coefficient is downward bias or upward bias. Okay? Now, using this real examples, I like to really tell you how to calculate all this bias. Okay, in the real world, maybe you may not able to to calculate all these numbers, but you will know that either upward bias or downward bias. In other words, the regression you run it is a biased. Okay, all right. So for teaching purpose, I have this correct model. Then I have the model which is the one you estimate. And I need to have one of the model, we call it auxiliary regression. Okay, so let me write down something here. I hope I can make it very clearly, okay? So the first one is correct model. This is correct model. Okay, I have Y. I'm using the notation of the beta, just usual. Beta 1, so I have N, beta 2, P, and beta 3, I. So I put it, this is a 1. Okay, then I will have the one estimated. I call it estimated model. So which is Y. And since I omitted the important variable P, I just have N and I. Okay, so I will change the notation. Okay, to say that the estimates are different. Okay, so this I'm using gamma. And since I will just using the same orders of the variables. So I'm going to using gamma 3 for I, since I don't have P. Okay? All right. So this is what the second one. This is the one you estimated. Okay? Then I need to have one called auxiliary model. What do we mean by auxiliary model? Auxiliary models say that using the one you omitted, okay, which is P, as a dependent variable. So I'm using the different notation again. And using the model you already estimated. Understand what I'm saying here? So this will be alpha 1 and also alpha 3 I. This 1, 2, 3 is follow the order of the original correct model. The auxiliary model is going to help you to find out, okay, whether the model you estimated are either downward or upward bias. Okay? So what do we mean by this one? Okay, this is the model we really wanted to check the coefficient, also the significance of all these variables. But the auxiliary model is just, maybe we call it auxiliary regression. Not the really model we wanted, okay? But model is not much difference, but I just want to look at it's a little bit difference. The auxiliary regression is help you to understand the relationship of the omitted variable and the variable included in the model you estimate. Understand what I'm saying here? So, how do you think? What's the P and N related? P is the populations, right? What's the N? N is competitors. Well, thinking about this one, okay? When the auxiliary regression run it, we do have positive sign or negative sign. Okay? If we have the positive sign, means the P and the example you have it, the P and I has positive relationship, right? When we say this is slope, right? But actually, for this regression, we're not talking about the slope. We just want to say, see the relationship either positive or negative. So if we have the positive, means the slope is positive. Therefore, the relationship of P and I is positive, right? So this one can be positive or negative too. Okay, so let's see this one. This is the correct model. This means N, P, and I, each independent variables, play its own role to the relationship to the Y. Okay? Now, this is the estimated model. You omitted P variables. Means only N and I play the role to, okay, this is to the Y. But where is the P? Where is the P? This auxiliary regression tells us that P, although it missed, you didn't see P here, but P indirectly plays some relationship with the relationship with N and I. Understand what I'm saying here? Understand what I'm saying here? Okay, this is P. If I have the P variable here, the P individually play its own role to the relationship with the Y. However, if I don't have P, then indirectly P is using the relationship with N and I to indirectly play his own relationship to the Y. But it's not vividly in the regression model, but indirectly embedded in the N and I. You see what I'm saying here? Understand what I'm saying here? Okay? So, in other words, N, the relationship with N and Y here, is not only itself, just like this, but also carry some burden from the P to the Y from here. Okay? So the same story is here. Here, the I play its own role plus the P's role to the Y variables. So this, the model you estimated N and I without P, so either one of them, those variables included in the model really carry the burden of some part of relationship with the omitted variable to the Y variables. Okay? All right? So this is the number we can see how that bias coming from. Okay? So I'm going to run another regression, which is I already did it. Okay, this is the one. Look at this one, okay? Look at this one. This is the one I run the P with N and I, okay? It's this. Okay? All right. So how does that bias coming from? Okay, now we look at these numbers. Okay, with this output, you can see what the all this estimation from, right? So what is the beta? So beta 1. So if I run this one, the coefficient of the N is gamma 1, but the correct one is beta 1, right? So there's a difference between gamma 1 hat and the beta 1 hat. Okay? So the gamma 1 hat minus beta 1 hat is what we call the bias. Now, what do we have? The gamma 1 hat is this one. Let me see. Where do I put this one? Here. Okay? The gamma 1 here I have is negative 14A7. Okay? 14A7. Something. Okay? Minus, what's the beta 1? Minus 9074. So what's the number? Please calculate it for me, okay? Like 6 or 8, 7, 5, 9, 7. Am I right? Right? Okay. And let's look at how does this coming from. Okay, this is from the relationship to the P and the alpha 1, right? Because we don't have P here. Okay? So, the relationship of the P and N we call alpha 1. Okay? Then the original P, we don't have the beta 2. We don't have beta 2 here, right? But we do know that this is positive or negative. But in this example, it is positive. Okay? So we know that this is positive. And from our examples, the P and N and I, all positive. Right? Okay? So we have the positive here. We have the positive here. So the bias is from the relationship of the P and the I. Okay, the original P is beta 2. So in other words, individually, if I have the P has the relationship with the Y is beta 2. But since it is omitted from the variables, then indirectly through N to affect the Y. Okay, and the coefficient is alpha 1, and the original is beta 2. Okay, so the bias is equal to okay, so what is the alpha 1 here? This one. Okay, 21392. 21392. What's the original beta 2 here? Is 0. Would you please calculate this one? Now I cannot do it by myself. But in fact, since if I run these regressions, I would not know that P should be in the model. But the professors ask you that maybe P should include in the model. So therefore, you may be able to understand this is a positive relationship or negative relationship. In our example, this is positive and this is positive. So what's the number of this one? 7587. Isn't it exactly the same? How beautiful the math. You see what I'm saying here? In fact, originally, in the real world, I mean, when you do your thesis, okay, you may not have the number like this one, but you should know the relationship. Therefore, you know that it's upward bias or downward bias. So would you like to check the gamma 3 again by yourself? Practice. So this is going to say that gamma 3 minus beta 3 is what? And this is equal to alpha 3 beta 2. Would you please calculate this number for me again? What's the number for? 1.0344. 1.0344, something like this one. And how about this? Look at this, alpha 3 times the beta 2 hat. So alpha 3 is this, right? This one. Like this. Zero. 3, 4. Okay, just a little bit difference. It's close enough. Huh? This is. Oh, okay. This is positive. This is positive. So it is positive. So it should be positive, right? Okay? This is our class activity number 5, due next week. I'm using I'll give you examples. Due next week. I wanted to learn it, when all this idea is fresh. Without delaying, just vividly into your mind. You see what I'm saying here? That's how important. Does anybody learn musical instrument before? Anybody learn musical instrument before? Okay, what kind of instruments? Piano? Pianos, right? When you go to the piano lesson, then you practice and you show your performance to your teachers, right? Then she will or he will correct the mistake you made it, right? So what does the teacher usually ask you to do? Practice immediately, then correct it immediately. Okay? That's the moral of our assignments. Okay? Never delay until you forgot. Or never delay until you're laziness. You see what I'm saying? This is the attitude of learning. Okay? So understand what I'm saying here. Okay? So, I'm saying this one again. Since this is a teaching purpose, I can have the exactly numbers from the examples to know the correct model and the model you estimated. Usually, we don't have the correct model. If I have the correct model, then I will do the correct model. How should I make a mistake like this one? Okay? But most of the time, you don't know that you made mistakes until someone tell you that. You may omit important variables, then immediately you can relate it. Those what you learned here. Then you ask yourself, what kind of variable you omitted? And what's the relationship with the original y? Then if I'll see also this relationship with all the variables already included the model you estimated, then you will know that, wow, if I omitted these variables, I may cause downward bias or upward bias. Okay, is that clear? All right. So this is all about the number one, omitted variables. Therefore, omitted variable is very, very serious problems. Omitted important variable. I mean, omitted relevant variable is an important problems for model specification. Okay? All right. Any questions about this one? And from our textbook, our textbook from page 176 until 181, 182, is all about omitted the expressions about the omitted variable. And I like just use this example to show everything included in the content. Then when you read it, the parts, then you may understand it. What's the material? What's the author trying to say? Okay? And although that it's hard to detect the omitted variables until you really understand or really familiar with all the literature review about the subject you are studying. And in this case, I think your advisor will be the one will help you to do this job. Okay? All right. All right. And let's go to the section 6.2, which is called irrelevant variables. I think this one, I'll just go through the examples from our textbook. Okay? And the textbooks is also using this examples. Okay? And on page 184, equation is 6.13. You all see that? Go to the page of 184. Equation 6.13. Okay, this is the regressions with MPI and also included one of the irrelevant variable, which is called A. Here we don't have any data set to play with. So let's just see the examples from our textbook on page 184, equation 6.13. Okay? This is the model with another irrelevant variables called A. And the definition of the A here is talking about the last 3 digits of the street address of Ice Woody restaurant. So the last 3 digits of the address is nothing related to the customer's bills, right? So this is what we call irrelevant variables. Okay, how do I know this is an irrelevant variables? Everybody sees 6.13. How do I know A is an irrelevant variables? Anybody tell me? Why A is an irrelevant variable? How do I know? How do I know? From the textbook, you're unable to see the p-value, right? But you can see what? T, right? You know that test statistic. In other words, you can use the critical value approach, right? Tell me what's the critical values from this equation. If I'm using alpha is 5%. Now I have another variable called A here. So I have this one, 4 plus A. Okay, what's the critical value? And the A here, if I use two-sided, alpha, two-sided, what's the critical value? Two-sided, 5%. What's the critical value here? To locate the critical value, you need to know the degrees of freedom, right? What is the degree of freedom now? 33 minus 1, 2, 3, 4, 5. So 33 minus 5, the degrees of freedom is 28. The original one, this is 29, right? This is 29. Since I have 3 variables, including intercept, so using 33 minus 4. Now I have 4 variables, so I have to minus 5. So 33 minus 5 is 28. So according to the degrees of freedom, 28, and two-sided for 5% is 2.048. And since this is two-sided, so it's positive or negative. So what's what's the t-values? We have it here. For A, is positive 0.61. So which falls on the which region? Non-rejection region, right? Since it falls on the non-rejection region, therefore, do not reject the null hypothesis. Means there's not enough evidence to show, to infer that beta 4 is not equal to 0. So it is not significant. It falls on the rejection region, right? You know, what I'm saying here is all refer to the chapter 5. So without knowing without have the foundation of chapter 5, how do you continue to learn the rest of the chapters? You see what I'm saying here? So, A is an irrelevant variable. Okay? And it is important to know that the authors recommend, okay, the author recommend this 4 specification criteria on page 184. It means that the author suggests using this 4 specification criteria to check whether it is an important or not important variables. Okay? And what are they? What are the 4 specification criteria? The first one is, of course, theory. Always go through the theory and always go to the literature review. Okay? So whatever, just go through the literature review. The second one is t-test, and I just show in the t-test, right? So for this variable A, the t-test tells us that A variable is not significant, which may is an irrelevant variable in this model. Okay? Then the third one is adjusted R-square. What's the adjusted R-square here? We have it for the models with A variables. Is, according to the books, adjusted R-square is, we'll see this information from the textbook, right? Adjusted R-square is equal to 0.569. Okay? And what's the one without it? Is 0.578. So it's reduced. Adjusted variables reduce. We wanted to include the variable. If we have one more variables included in the model, the adjusted, if it is important, the adjusted R-square should increase. But here it decreases. So by using the criteria of adjusted R-square is also a good one. Okay? All right? Then number 4, bias. This is the bias. This is the bias we just learned. Usually the bias is for important variables. Okay, for the irrelevant, the bias always very, very small, since it is not significant. Okay, so if we're asking to do this specification problems, then this 4 criteria is important. Although, for practice, we may not use the theory since, we already think that the theory is already, there, and we all know it. So we can try using adjusted R-square. We can use the T statistics, and we can use the bias. Okay? And, here, I like to show something which is also important for all of you, and you all know how to do it from eViews. Okay, there's some statistics tools which will also help you. Okay, let's take a break. Just a few minutes. Okay, let's take a break. Then for 10 minutes, okay?